So here we are, we've seen how the transversal Snake River Rift, there's our epicenter down in Chile, located on the Pacific Ring of Fire. So if you look here once again, out in the center here, and we're going to do a little Wikipedia thing on this also, but look at the oceanic convergent boundary. You can see them right here. Oceanic convergent boundary, oceanic transformal fault, right there. That means it's sliding along, you know, one sliding in one direction, one sliding in the other, or one standing still and one sliding side by side. They're not subducting. Now subduction, that's going to happen at the continental, at the edge of the oceanic plate, closer to the continental plates. Oceanic convergence, we have some right there, huh? Oceanic spreading rift. See, that's the majority of the action right there. Oceanic spreading rift. If you look at that, here's Chile, we just looked at. Now out in the center, what's interesting too is when you get it to a larger world scale, let's bring that oceanic spreading rift back into the picture here. See it? It's the majority of the activity out there. So this is where the magma is coming back up and flowing towards the continent. And then here it's, along here it's subducting, flowing under the continental plate. So it's a subduction area. But let's get back to true north here. Pretty close. Let's take a look right down in here to Yellowstone Lake. You know, they didn't know it was a volcano until they got up in space and looked back at it and went, oh, there's the volcano. There's the caldera, the cone, up to 200 miles across, 275 miles across in places. And you'll see in this next little blurb on Yellowstone, supervolcano, how craters of the moon, right here, is an older, dated Craters of the Moon National Monument. So these are all different lava flows, and this is where the magma plume has poked up through the crust, or the continental crust, as it circulated. So the crust is moving and the magma plume isn't as much. So it just, the crust kind of moves along. You'll see a rendition of that here in just a minute. But Yellowstone. Supervolcano.
Geysers is one of nature's greatest spectacles. It's why millions of visitors each year come to America's own.
Let's look at it from the beginning. Okay, sorry. There you go. Let's try it again.
And home to one of the world's largest supervolcanoes. Beneath the scenic geysers and waterfalls, an eruption 1,000 times larger than any in human history awaits. It's happened before. Less than 1 million years ago, it devastated more than half the continent, and it could happen again.
There will definitely be additional eruptions in this area.
And not just one, but a series of monstrous eruptions. 1 million times more powerful than an atomic bomb.
It's absolutely devastating. Everything would be killed.
Destroying thousands of square miles of land and countless lives across the Northwest.
It'll just be over. It'll be toast. It'll be finished.
We go beneath the earth to probe the volcano, reveal for the first time the source of its power, to discover what will happen when the sleeping giant of Yellowstone awakens and becomes a mega disaster. The dance of geysers is one of nature's greatest spectacles. It's why millions of visitors each year come to America's oldest national park, Yellowstone. Its spectacular beauty inspired President Ulysses S. Grant to protect these 2 million acres of northern Wyoming wilderness back in 1872, and it's been a haven for outdoor enthusiasts ever since. Its incredible hot springs, bubbling pools of mud, unearthly ponds, and the most celebrated natural feature, the Old Faithful Geyser, are some of nature's greatest wonders. But beneath this primal beauty simmers a hidden threat. 5 miles below the waterfalls and mountain peaks lies the heart of a supervolcano, a constantly moving cauldron of molten rock the size of Mount Everest. Over countless millions of years, it fills with lava to the breaking point. Like a bomb with a hidden timer, it finally explodes.
We don't know how long it's going to just sit there before it decides to go off.
If sometime in the future it were to erupt, as it has before, the Yellowstone volcano would overwhelm everything within 100 miles and disrupt lives across the globe for years. The first sign of trouble will be increasing seismic activity. The ground would rise as pressure from the molten rock begins to grow.
There would be a lot of ground deformation, and then if it was moving up slowly enough, we would actually start seeing large changes in the geyser bases.
Finally, the lava would shatter the Earth's surface with an explosion 10 times larger than Mount St. Helens. A hurricane of hot gases would spread out in all directions as the ash cloud reaches 80,000 feet into the air. Already larger than anything man has experienced, this would be just the beginning of a Yellowstone super eruption. Within days, a second enormous eruption would begin, then another. Soon, a ring of monstrous explosions 50 miles wide would be spewing molten rock and burning gases across the landscape.
Certainly within 100 miles of Yellowstone, there wouldn't be much that was not destroyed.
High in the atmosphere, the ash cloud would surround the planet, sending temperatures plunging. Global agriculture would fall into chaos. How do we know it will happen? It's happened before. The evidence is etched into the geologic record of past supervolcanoes. There are 1,500 volcanoes around the world. But there are fewer than 10 supervolcanoes, the ones with the potential to not only destroy the surrounding area, but to create a global disaster. And Yellowstone is one of these supervolcanoes.
Imagine something 10,000 times the size of Mount St. Helens. It's almost unimaginable.
Unlike a conventional volcano with its crater atop a mountain, Yellowstone's crater is so large it can only be seen from the air. This is the rim of a monstrous crater called a caldera that collapsed into the magma chamber during the last super eruption. It's large enough to hold the city of Los Angeles.
People drive 35 miles, 45 miles commuting to work in that. Well, that's the distance across this caldera.
And this is only the last of 3 monstrous calderas formed over the past 2 million years.
The volcanic history of Yellowstone is really marked by these 3 giant cataclysmic eruptions. of the scale that we haven't seen in, history of man, really.
The first eruption vented somewhere around 600 cubic miles of material. And if you took all of that and you spread it out over the state of Texas, you'd have about 12 feet thick of deposits.
The second eruption was hundreds of times larger than Mount St. Helens, and it's the smallest of the Yellowstone supereruptions. The most recent one, known as the Lava Creek eruption, occurred 640,000 years ago. At the time, early man had yet to arrive on the scene. Exotic prehistoric animals roamed the North American continent. 5 miles beneath the earth, however, a magmatic cauldron 3 times the size of New York City was coming to a boil.
There would have been hundreds to thousands of earthquakes, becoming fairly large, so there'd be a lot of shaking as the hot rock was moving up.
1 million tons of molten rock heated to 1,800 degrees Fahrenheit pressed its way to the surface. Jets of superheated water suddenly burst through the cracks in the Earth's surface, shooting into the air. Hundreds of geysers were erupting over 500 square miles.
We get explosions out of the hydrothermal system that put holes in the ground as big as a mile across. So they're big events.
But this was just the overture before the main event. After days of increasing earthquake and geyser activity, under mounting pressure from magma and superheated gases, Yellowstone's last super eruption began.
Material may have started to leak out of one side, perhaps forming part of the edge of the fracture zone. As you start to decrease the pressure, it starts to then explode.
With the power of a hydrogen bomb, a monstrous cloud of searing ash and melted rock shot into the stratosphere at supersonic speeds. The heavier debris fell back to the ground, turning into colossal pyroclastic flows.
It was sort of like a hurricane made up of 800-degree ash and pumice and hot gases. Just wipes things out completely.
For miles, these lethal rivers of ash and gas cooked animals alive and brushed forests aside like twigs.
They extend actually outside of Yellowstone into Idaho and into the Teton region. Some of this material flowed down and actually covered parts of the floor of Jackson Hole. So these scenes extend tens of miles away from the actual eruption location.
For days, the Yellowstone volcano continued to heave tons of molten debris into the air and devastated the nearby terrain. Then, across the caldera, another colossal explosion. Then another. Eruption after eruption began shooting more and more lava and pulverized rock into the air.
Typically, when these eruptions begin, they begin at a single vent, and the event may then get larger, moving out along some sort of a fracture system.
Yellowstone had turned into a super eruption. Its devastation would reach around the world. Yellowstone's last super eruption occurred 640,000 years ago. It started as a single massive volcano, but soon turned into a series of eruptions, exploding with the full force of a supervolcano.
The entire sequence of pyroclastic explosions that formed the Yellowstone caldera may have taken as little as 2 weeks to happen.
Pyroclastic flows slashed across the landscape, obliterating thousands of square miles. Separate clouds of ash fused into a massive column of smoke. Winds drove it across the country, darkening the sky for hundreds of miles.
During the eruption of all this material, that's when the caldera would have started forming.
In a final massive display of nature's fury, hundreds of square miles of mountain dropped thousands of feet into the pit of roiling magma.
The Gallatin Range and the Madison Range and the Mount Washburn Range to the north continued somewhere into the Yellowstone region. These mountain ranges were destroyed. Now, when I say destroyed, I don't mean they were blown to smithereens into the atmosphere. Much of it just fell back into the magmatic system, just fell back into the cauldron, if you wish, up the caldera itself.
We're talking about mountains that might be 12,000 feet high, that are now, the ground surface is on the order of 8,000 to 9,000 feet high. So 3,000 foot of mountain that is no longer there.
Finally, after perhaps weeks of constant activity, the Yellowstone volcano subsided. But the devastation was far from over. A global disaster was about to begin. 2.5 trillion tons of sterile volcanic ash drifted with the winds and buried 2,000 square miles of the North American plains, destroying much of the continent's plant life.
The volcanic ash that's ejected high up into the atmosphere and then falls many, many miles away, that goes as far as Louisiana and some of the states along the Mississippi River. So quite an ash cloud.
The lighter particles remained in the air for more than a year, forcing temperatures to plunge across the hemisphere.
It acts as a veil and cuts out the sunlight, and so it cools the climate below. I think there would certainly have been climatic changes due to Yellowstone. We estimated 3 to 5 degrees Celsius drop in temperature, which is quite severe on a global basis.
5 degrees was enough to kill off much of the tropical plant life across the globe. Over the next year, animals died from lack of food as the ash continued to block out the sun. It took years for the planet to recover, for sunlight to reach the Earth's surface, for plants to push through the layers of ash, for animals to repopulate the continent. This Yellowstone eruption 640,000 years ago changed the face of North America. But that wasn't the only supereruption to ever strike the area. Besides the 3 calderas found near Yellowstone Park, geologists have discovered a series of eruptions and supereruptions that extend back 16 million years.
There have been a series of volcanic eruptions similar to those that occur at Yellowstone, and there are all sorts of calderas that are preserved in the Snake River Plain in Idaho and extending back into Nevada.
To date, 15 calderas of more than 140 large eruptions have been mapped. They create a trail running northeast to southwest and are an indication of what geologists call a hotspot. A hotspot is a portion of the Earth's mantle that contains a massive pool of partly molten rock.
There is an area within the Earth's mantle, deep underneath where we live, that is molten. And it's causing a lot of heat to rise towards the surface, and that heat causes melting in the crust. And so we get large magma chambers.
From time to time, as the pressures build, the magma works its way to the surface and explodes.
There are 20 or 30 hotspots around the Earth's globe, such places as Hawaii and Iceland. These are long-lived zones of active volcanism.
The Hawaiian Islands, for example, were created one by one over the millennia by an underwater volcano. Though it appears as if the volcano had moved along the Earth's surface, in reality, the area of molten rock has remained relatively stationary. It is the Earth's crust which has moved. The same is true for the Yellowstone hotspot. Above its magma chamber, the North American plate is slowly sliding to the southwest, about an inch a year. With each new eruption, a caldera is formed and appears to be further to the north.
We find calderas all the way back into northern Nevada, and it's possible that there have been as many as 50 eruptions, just as big as some of the ones that have come out of Yellowstone.
With a history of multiple cataclysmic eruptions, Yellowstone is becoming the most studied supervolcano in the world, and its hundreds of yearly earthquakes, thousands of geysers, and massive magma chamber make it one of the most geologically active regions.
This thing is a breathing system, and it's a dynamic system, so I called it a living, breathing, shaking caldera.
At the heart of these super eruptions is thought to be a mantle plume, an upwelling of molten rock rising from deep within the Earth. But no one could be sure. Recently, however, scientists have been using extremely sensitive monitoring systems to capture data from earthquakes centered around the world. The data has helped create the first 3D image of the source of Yellowstone's power.
Once we put out an array of seismographs with sufficient resolutions, like getting a high resolution CAT scan, we saw that this thing was going off laterally about 150 kilometers to the northwest, and it is basically coming up from a depth of about 600 kilometers.
Yellowstone's magma source begins 450 miles below the surface, and surprisingly not directly under the park, but 150 miles away beneath the Montana-Idaho border.
It was totally unexpected and would not fit into anyone's textbooks or classic ideas.
As the research continues, scientists are realizing how little they really know about the Yellowstone volcano.
Since humans haven't seen an eruption of this magnitude, we're somewhat challenged to know exactly how the systems work.
One thing is known for sure. If Yellowstone erupts again, pyroclastic flows will destroy everything near the volcano, and its ash cloud would overwhelm humanity across the globe. And predicting its eruption could be a matter of life and death. Yellowstone. Its dreamlike natural beauty may sometime in the future turn into a nightmare. With little warning, the gigantic volcano could awaken and explode, putting the entire planet at risk. Unlike most disasters, such as tornadoes or hurricanes, which are short-lived and localized, a volcanic supereruption in Yellowstone would have global effects for years. Its impact would be on the scale of an asteroid, large enough to change the way we view our history.
For a long time, Earth history was gradual changes, slow changes over long periods of time. And now we realize that every once in a while, boom, out of the sky comes something catastrophic.
Most scientists believe an asteroid caused the disappearance of the dinosaurs 65 million years ago. But new discoveries suggest volcanoes can cause planet-wide devastation as well. One of the early volcanoes fueled by the Yellowstone hotspot left a gruesome graveyard 1,000 miles downwind.
12 million years ago, the wildlife in Nebraska was similar to what we have in Africa today. We have elephants, rhinoceroses, camels, horses related to zebras, all kinds of critters that aren't here anymore.
Their bones, discovered in northern Nebraska, tell a distressing story of Yellowstone's impact. They were found buried under several feet of ash, volcanic debris linked to a supereruption.
We first thought that maybe all these critters had been buried alive in ash, like the people at Pompeii. But the more closely we looked at the fossils, it turns out that that wasn't true.
Most of the fossil bones exhibited evidence of a strange illness, a clue to why so many animals died.
It has the extra growth of bone on the leg bones and on the jaws.
The unusual bone growth is a signature symptom of Marie's disease, a rare lung condition resulting from breathing large amounts of dust or ash.
Well, this is a jawbone of a camel from the ash bed. This shiny bone here is healthy. It's normal fossilized bone. And you can see where the healthy bone stops and this new growth begins. You can see the color changes and the texture changes. It looks like a sponge, and this is the diagnostic feature of HPOD, or Marie's disease.
Voorhees believes that ash from the Yellowstone hotspot caused Marie's disease in these animals.
Ash is nothing but very small pieces of glass. That's how you can tell volcanic ash from other types of fine powdery rocks, is that volcanic ash sparkles because it's made out of...
The fact that the Earth's crust moves over the magma plume, and that the plume, now they're able to use high-def techniques to find out where that, have a better image of that plume itself. One of the things that was mentioned there was the formation of islands, suboceanic. You take a look at, by the way, 100 miles, See, here's Gardner, here's Bozeman, Quarter Circle Ranch. Where's Bozeman at? Missoula way up there. I know that's at least 200, almost 300 miles away. So Bozeman's got to be right. Oh, there we go. Probably right over in here somewhere. Mission Field, Haggerty, Briar Creek, Bozeman, Yellowstone International Airport. There it is. But if we get back out here ways, let's go ahead and let's search for them. I like to kind of get out there a ways and see what kind of tectonics we have around here. Remember, tectonics, the ring of fire, and we have your basic plates over here. You have the continental convergent boundary, continental rift boundary, continental transformal boundaries. You have convergent, spreading rift, transformal faults, and the subduction zones, all associated with plate convergence and movement of the Earth's crust. We get out here a ways. Get a little further out. If we go to that USGS site, so if we get back into your topic 3 here, down here in topic 4 we also have that, the reminder on Google Earth. But here's your actual link right here in topic 3. It's Google Earth download, USGS real-time earthquake. So you get into the Google Earth setup. And I've already got it, so I don't need to open that up. But that'll get that on your computer so that you can start to play with it yourself. Use it. The whole idea is that geothermal energy is more readily available along tectonic interfaces, such as Yellowstone is a fault, transverse fault, and there's magma close to the surface. But surprisingly enough, Montana is way down the list, and we'll see that here in just a few minutes. It's way down the list as far as taking advantage of geothermal energy. I don't think there's actually any geothermal power producing plants in Montana. There are some direct applications meaning hot springs, heating homes, or using it for greenhouses. But as far as generating power, that doesn't seem to be happening in Montana. But you get your Google Earth going. So just exactly what are the 10 deadliest volcanic eruptions?
Alaska. Finally, the search for brown bears begins. Denali Highway, low on...
Yo. So now, moving forward, what is it? You got Mount St. Helens out there, right? Some of you remember the results of that. I was here in Missoula for the ash cloud that paralyzed the city.
Spring.
Try refreshing that.
Spring, 1980. Mount St. Helens is one of the major peaks in the Cascade Mountains. It's an area of outstanding beauty, rich in wildlife. For over 120 years, the volcano has been quiet. But in recent weeks, it's been rumbling. Nobody is sure what to expect. Then, on May 18th, 1980, a 5.1 magnitude earthquake rocks the mountain. Within 10 seconds, the volcano's northern flank collapses in the largest landslide in recorded history. It releases millions of tons of magma in a colossal explosion. A cloud of searing gas and rock, known as a pyroclastic flow, races over the surrounding countryside. Forests are flattened. Four miles below the summit, an enormous lake is choked with debris. The eruption continues to shoot poisonous steam and ash miles into the air.
It was just, again, astounding is the best word to describe what happened in 1980 here at Mount St. Helens.
The northern slope of the mountain is buried in several feet of ash. Virtually all life is extinguished. 57 people are dead. They include loggers, campers, scientists, and a reporter. Some are up to 13 miles away in areas considered safe. The plume of steam and ash rises miles into the sky for the rest of the day. The drifting ash cloud disrupts air traffic for hundreds of miles. The scale of the destruction is enormous. Across more than 200 square miles, the surge of ash and rock incinerates trees. Thousands of birds from more than 100 species disappear. Billions of insects are gone. Deer and elk are wiped out. This vast area of devastation becomes known as the blast or blowdown zone. Nearer the crater, ash and rocks from the landslide litter the northern slope of the mountain. It looks like the moon. It's called the pumice plain. It's directly below the crater. 4 miles from the volcano, the enormous Spirit Lake is scarcely recognizable.
The avalanche has lifted its bed more than 200 feet. The surface is smothered in dead trees. Hundreds of species of aquatic life, including insects, amphibians, and fish, are killed.
It was black water, and it degassed and bubbled, and there was hot springs that were coming up. If you were to put your fingers into your wrist and wiggle them, you wouldn't even be able to see your fingertips. That's how grossly modified the water was.
Mount St. Helens is now a lifeless jumble of shattered forest, rock, and ash. It's hard to imagine life will ever return. The eruption was so powerful, it altered the shape of the mountain. Mount St. Helens was a typical cone-shaped volcano, known as a stratovolcano. But the landslide has torn 1,300 feet off the summit, leaving a gaping crater a mile wide and 2,000 feet deep. It's the largest volcanic eruption in North America in nearly a century.
There you have it. So let's we'll take a look in here at the Pacific Ring of Fire. So stay tuned for lecture 3 in our series today. Then we want to get into looking at our smart geothermal and some of the residential applications, Geothermal Energy Association, and the TransEnergy project, and some of the ways we use geothermal energy. So stay tuned for lecture 3.